Welcome everyone to the public defense of Nicolas Leenaerts. I warmly welcome Dr. Jonas Dore from the University of Washington in Seattle, Professor Sarah Racine from McGill University in Montreal, who will attend this defense online, and Dr. Hendrik Peuskes from UPC KU Leuven and the Psychiatric Clinic Alexiane in Tiene. I also welcome the jury members from KU Leuven, Professor Lucas van Oudenhoven, and the promoters, Professor Elske Friese, Dr. Jenny Cesarini, and Professor Stefan Sunaert. My name is Patrick Dupont, and I will chair this defense. And Nicolas, you have about 30 minutes to present your work.
Imagine the following. You're having a difficult day at work. Your boss comes up with a bunch of new deadlines, and then there's this one annoying colleague who just keeps nagging and nagging and nagging. You feel this craving rise inside of you, and you want to eat something sweet. And then you remember that there's this pack of cookies inside your desk that's been waiting for exactly this moment. So you eat a cookie, and another one, and another one. And you feel that you lose control, so you eat another one, and another one, way more than you intended to. Or perhaps you're not into cookies, and you wait until you get home, and you open a bottle of wine, pour yourself a glass, and drink it. You feel calmer, more relaxed, so you drink another one, and another one, and another one, way more than you wanted to. Now, if it happens once, that's okay, but if it happens repeatedly, then it can be problematic. For example, in Bulimia Nervosa, where patients binge eat, meaning that they consume large amounts of food within a short period of time and lose control. Afterwards, they compensate, for example, through vomiting, excessive exercise, or not eating. Now, drinking more than you intended can be part of an alcohol use disorder, where patients consume large amounts of alcohol, for example, in binge drinking episodes, which then impact their daily life. Now, both disorders are widely prevalent. For example, between 2 to 3% of all individuals will meet the criteria for bulimia nervosa in their lifetime, and between 9 and 29% will meet the criteria for an alcohol use disorder. So we all know people who have struggled, are struggling, or will struggle with one of these disorders. And what if they would want to get treated? Well, then they're in the minority, because only between 15 to 20% of all patients will seek treatment within a given year. And what are their chances to get better? Not that great. Only a third of patients will achieve remission after treatment, meaning that they no longer meet the criteria for bulimia nervosa or an alcohol use disorder. So we need to bump these numbers up. How? Well, develop better treatments. And how can we get better treatments? Well, we first need to know why patients binge eat and why they binge drink. And that's what I wanted to explore with my PhD. More specifically, I wanted to study the relation between 4 factors. The first one is stress and negative emotions. What is stress? What are negative emotions? Are they the same? No, not exactly. Stress is the physiological and psychological response of our body to a demand, a stressor, which threatens our steady state. For example, a boss that comes up with a new deadline. Negative emotions is a term for a group of emotions such as sadness, anxiety, anger. For example, the anger that you felt at that one annoying colleague. The second factor is craving. Now, it's a term we often use in a clinical context. For example, this patient is craving alcohol. But what is craving? Is it just any desire? Can you say, oh, I'm craving that the government doesn't increase the price of stamps this year? No. Craving is a very strong feeling for something specific, such as alcohol or a binge eating episode. That is craving. The third factor is negative urgency. And some of you might think now, well, I've never spoken these words out loud ever in my life. And indeed, it's not a term we often use in the clinic, but it's something we're confronted with on a daily basis. Namely, negative urgency is a tendency to display rash action or impulsive behavior when we're stressed or experiencing negative emotions. For example, when your boss came up with a new deadline, you got really angry, wrote an angry email, and then felt really proud. But after an hour, you were like, what the hell did I just do? Well, that's an example of negative urgency, which is a very interesting neurobiological foundation. Namely, it is thought that it is the result of a miscommunication between brain areas. One of them being the frontal cortex, which is our controller, and the other one being the striatum, which is our actor. So it could be that the frontal cortex does not exert enough control over the striatum. But how do brain areas communicate? Well, they do so through neurochemicals, such as dopamine. So it could be that a disturbance in dopamine transmission leads to a miscommunication between brain areas, and that this leads to negative urgency. The fourth factor is reward processing. Now, some of you might think, well, rewards, that's something I get again. Well, indeed, rewards are everywhere. For example, when we're playing a game and gathering coins or gathering gems, or when we're deciding to buy something now or save our money to buy something later. And that's the type of reward processing that we were interested in, the choice between a reward now and another larger reward later, which also has an interesting neurobiological foundation and where, again, our frontal cortex, our controller, plays an important role. Now, how do we study the relation between these different factors? Well, we use three distinct modalities. The first one is the experience sampling method, abbreviated to ESM, which is a bunch of difficult words to say that you follow participants in their daily life, for example, with a smartphone application, and ask them how they are feeling, what they are doing, where they are at, and who they are with. The second modality is magnetic resonance imaging, MRI for short, which is an imaging modality that allows you to visualize the brain, not only the structure, but also brain activity. The third modality is PET-MR, where we've also got positron emission tomography, which allows you to look at neurochemicals such as dopamine. Now let's focus on a first modality, ESM, and the hypotheses that we wanted to test there. Namely, we wanted to see whether negative emotions in patients with bulimia nervosa or an alcohol use disorder are more likely to give rise to feelings of craving for alcohol or a binge eating episode. But of course, when we're experiencing craving but can control these emotions, there's not that much of a problem. So we also wanted to see whether negative emotions are more likely to give rise to rash action. In other words, whether patients display more negative urgency in daily life. Then, we wanted to see whether at moments of high craving and high rash action, they were more likely to binge eat or binge drink. How did we do this? Well, with a study. And every study needs study participants. So who did we include? Well, all of our participants were female. Namely, we had 53 patients with bulimia nervosa, 51 patients with an alcohol use disorder, 19 with both, and 76 healthy controls. And we followed them over a period of 12 months. But you can't ask people questions every day for 12 months. That would be way too intense. So we only had 7 bursts of 3 weeks of data collection. But even in those 3 weeks, we did not collect data every day, only Thursday, Friday, and Saturday to limit the impact of the study. And on each of those days, we asked 8 signals, 8 pings, where we asked participants questions on how they were feeling, how they were doing, what they were doing, who they were with, and where they were at. That way, we got a large amount of data. Let's look at it. First, for binge eating, as indicated by this cookie here. In this graph, you can see negative emotions on the x-axis, with 0 representing the average within a person, and negative numbers representing lower levels than average, and positive numbers representing higher levels than average. On the y-axis, we've got subsequent rash action. So rash action at the next signal after the negative emotions. And here you can see in the patients with bulimia nervosa that there is a significant relation, as indicated by this S here. Namely, when patients experienced more negative emotions than average, they were more likely to then display rash action by the next signal. This was also the case for our healthy controls, but less so. So negative emotions predict rash action in patients with bulimia nervosa, and this is more pronounced than in controls. What about craving? Well, that's what you can see here. In this graph, where we've got negative emotions and subsequent craving. And again, there was a significant relation in patients with bulimia nervosa, where higher negative emotions were linked to then experiencing more craving at the next signal. In contrast, this was not the case in our healthy controls. So negative emotions predict rash action and craving, but how are these two then related to binge eating? Well, that's what you can see here. In this graph, we've got rash action on the x-axis and subsequent binge eating on the y-axis. And again, there was a significant relation, wherein patients with bulimia nervosa displayed more rash action at one signal, they were more likely to have binge eaten by the next. What about craving? Well, that's what you can see here. And again, when patients with bulimia nervosa experienced more craving at one time point, they were more likely to then have binge eaten by the next. So rash action and craving predict binge eating in patients with bulimia nervosa. And then you might think, well, we're done, right? We've proven all our hypotheses. Well, that's not really the case, because negative emotions don't always lead to binge eating. What do I mean by that? Well, today I was very anxious to give this presentation, and I ate a lot less than I would usually do. And we also saw that in our data. Namely, here you can see the relation between negative emotions and subsequent eating, whether it's under-eating, normal eating, or overeating. And in our patients and our healthy controls, we saw that experiencing more negative emotions at one signal predicted not eating at the next signal, so they were less likely to eat. But what about if you just look at those moments of eating by themselves? Well, then indeed we did saw a significant relation, where negative emotions were related to then binge eating in the future in patients with bulimia nervosa. So negative emotions can predict binge eating, but also not eating. Well, why is that? Well, in these analyses, we combined all the different negative emotions in one term. But in a subsequent machine learning analysis, we looked at how all kinds of individual variables were related to binge eating. And that's what you can see here, different variables and their relation to binge eating. And I just want to draw your attention to two variables. The first one is feeling down, which was a positive predictor, and the second one, which is feeling distressed, which was a negative predictor. So negative emotions could be variably related to binge eating, with some negative emotions being more positive predictors and others being even negative predictors. Now, those were the results for binge eating. Let's look at the results for alcohol use, as indicated by this glass of wine here. Now, you've all become experts on these types of graphs, but I will still walk you through it. In this graph, we see the relation between negative emotions and a subsequent craving for alcohol. And we can see that similarly, as in the patients with bulimia nervosa, when patients with an alcohol use disorder experience more negative emotions than average, they were then more likely to experience craving for alcohol. But something interesting happened on the left side of the graph. Namely, when they experienced lower than average negative emotions, they were also then more likely to experience craving for alcohol. In contrast, this was not the case in our controls. So we saw that negative emotions, both higher and lower, predict craving in patients with an alcohol use disorder. But what about drinking alcohol, drinking wine, drinking a beer? Well, that's what you can see here. In this orange graph, we see the relation for our healthy controls. And you can see that at lower than average negative emotions, they were then more likely to drink alcohol by the next signal. This likelihood decreased the more negative emotions they experienced, where higher than average negative emotions were not related to then drinking alcohol in the future. In our patients here in blue, we saw something similar, namely that lower than average negative emotions predicted future alcohol use. But in contrast to our controls, we saw that higher than average negative emotions were also predictive of drinking alcohol by the next signal. So negative emotions, both higher and lower, predict alcohol use in our patients. But what about binge drinking? Drinking a lot of alcohol. Well, that's what you can see here. But the story remains the same, where higher than average negative emotions and lower than average were predictive of binge drinking by the next signal. In contrast, this was not the case for our healthy controls. So what does this mean? Did our patients crave more alcohol, drink more alcohol, and binge drink more when they were feeling bad, but also not bad at all? Well, yeah, because a lot of people drink alcohol when they're feeling good. Namely, when this presentation will be over, at the reception, a lot of you will be drinking alcohol. So that is why we also looked at the impact of positive emotions. And that's what you can see here, the relation between positive emotions and subsequent craving for alcohol. And similarly, both higher and lower levels were related to then craving alcohol at the next signal. In contrast, this was not the case in our controls. What about alcohol use? Well, that's what you can see here. Our orange line is the healthy controls, and higher than average positive emotions predicted drinking alcohol by the next signal, and this likelihood decreased the less positive emotions they experienced, where lower levels were not predictive. In our patients, we also saw that higher than average positive emotions were predictive, but in contrast to healthy controls, we saw that lower than average positive emotions were also predictive of drinking alcohol by the next signal. What about binge drinking? Well, as we can see here, and the story remains the same. Both higher and lower levels predict binge drinking by the next signal, and this was also the case for our controls here. So we need to change whatever I wrote here and say that negative and positive emotions, both higher and lower, predict craving, alcohol use, and binge drinking in our patients with an alcohol use disorder. Let's recap. In patients with bulimia nervosa, we saw that negative emotions predict craving and rash action, and that these then predict binge eating. But we also saw that negative emotions can predict not eating. In patients with an alcohol use disorder, we saw that negative emotions can predict craving, alcohol use, and binge drinking, but that positive emotions can do the same. Now, those were the results for our ESM study. Let's now look at our MRI study and the hypotheses that we wanted to study there. Our focus here was stress and the impact of stress on reward processing, but not just any type. No, the type where you choose between a certain reward now and another later. For example, a cookie now and 2 cookies later. And we wanted to see whether stress causes patients with bulimia nervosa or an alcohol use disorder to desire more immediately available food or alcohol. And we wanted to see whether this is related to changes in brain activity, most importantly, in the frontal cortex. How did we do this? Again with a study and again with participants. But these participants were a subsample of our larger ESM study. So all of our participants were female, 25 patients with bulimia nervosa, 27 with an alcohol use disorder, and 50 healthy controls. And all participants needed to perform a series of tasks in the MRI scanner. First, our reward processing task, where patients with an alcohol use disorder needed to choose between a certain amount of alcohol now versus later. For example, 1 beer now and 2 beers later. And where our patients with bulimia nervosa had to do the same, but with food. And our healthy controls were split into 2 groups. Afterwards, we stressed them out. The participants needed to solve mathematical equations under time pressure. The system was rigged so they were always performing poorly, and then they got a lot of negative feedback. So we really stressed them out. And afterwards, we repeated the reward processing task. And that way, we could see whether stress causes patients to desire alcohol and food now. Let's look at the results. First, for food. In this graph, you can see tasks on an x-axis with pre-stress and post-stress reward processing, and the preference for immediately available food on the y-axis. You can see the results for the healthy controls and for the patients with bulimia nervosa. And something unexpected happened here. Namely, we saw that healthy controls preferred more immediately available food after stress, but not the patients with bulimia nervosa. Why is that? Well, in the introduction, I told you that not eating can be an important part of bulimia nervosa. And in our ESM study, we saw that negative emotions can also predict not eating. So perhaps that's the reason why stress did not cause them to want food now. But perhaps this is the case in our healthy controls, where not eating plays less of a role. What about brain activity? Well, that's what you can see here, namely the changes in brain activity after stress in our healthy controls. And you can see a decrease in activity of the frontal cortex, and this was related to wanting food now after stress. There were also changes in the brain activity of other regions, but these were not related to the behavioral results. But then, when we looked at the changes in brain activity in a patient with bulimia nervosa, it's not that we didn't find anything. No, we saw an increase in activity of the occipital cortex at the back of the brain. And this plays an important role in the processing of visual and rewarding stimuli. So it could be that there are changes in reward processing, but that these aren't simply related to wanting food now. Let's look then at the results for alcohol. Again, with the same graph with pre- and post-stress reward processing, but now with the preference for immediately available alcohol on the y-axis. And in line with our hypotheses, the patients with an alcohol use disorder preferred more immediately available alcohol after stress. But this was not the case for our controls. So this is in line with our ESM study, where negative emotions predicted craving, alcohol use, and binge drinking in our patients. And then, when we looked at brain activity, we saw that patients with an alcohol use disorder had a lower activity of the right supplementary motor area after stress, which is an area that plays an important role in motor inhibition and inhibition in general. So it could be a sign that our patients were losing control. And indeed, when we correlated the activity in this area with our behavioral results, we saw that participants who preferred more immediately available alcohol after stress were then also displayed a lower activity of the right supplementary motor area. So this preference could indeed be linked to a change in activity of this brain area. Let's recap. In our patients with bulimia nervosa, we did not find that stress increases the preference for immediately available food, but we did see changes in brain activity of the occipital cortex, which could indicate that there are changes in reward processing. In our patients with an alcohol use disorder, we saw that stress does increase the preference for immediately available alcohol, and that this is related to changes in activity of the right supplementary motor area. Now, those were the results of our ESM and MRI studies. Now let's look at the last modality, our PET-MR study. In this study, we really wanted to dig into the neurobiology of negative urgency. So our focus was stress, and we wanted to see whether stress causes changes in dopamine transmission and whether stress causes changes in frontostriatal connectivity. In other words, the control that the frontal cortex exerts over the striatum. And we wanted to see whether changes in these systems are related to rash action in daily life. We again performed a study, and again our participants were a subset of our larger ESM study. But we only had one group, namely 12 healthy controls. And all of them participated in the same design. Namely, we first had 2 segments where the participants laid in the scanner without performing any task. We just asked them to relax. And afterwards, we performed a control task, a control version of the stress task we used in the MRI scanner. So the participants needed to solve mathematical equations, but there was no time pressure, there was no rigged system, and there was no negative feedback. In the last segment, we used the stress task. So there was again this time pressure, this rigged system, and the negative feedback. In the blue segments, we collected PET data and could look at dopamine transmission then. And in the red segments, we also collected MRI data, which allowed us to look at frontostriatal connectivity. Let's look at the results. First, for our PET study. Here, you can see the changes in dopamine transmission after stress. And we saw an increased dopamine release after stress in the frontal cortex, especially in the lower regions, which are labeled the ventromedial prefrontal cortex, or VMPFC. So stress causes dopamine release in the VMPFC. What about brain activity? Well, that's what you can see here. In these graphs, we've got activity in the left VMPFC on the x-axis and activity in the right caudate and left caudate nucleus on the y-axis. The caudate nucleus is an important part of the striatum. Before stress, we saw the blue line, a positive relation, meaning that when activity in the VMPFC was high, so too was activity in the caudate nucleus. But after stress, we saw a dampening of this relation, meaning that when activity in the VMPFC was high, then activity in the striatum did not follow along. Perhaps this is a sign of inhibition, that the frontal cortex exerts control over the striatum. This could be adaptive because under stress, we want to have more control over our actions. What did we see then? Well, participants with more dopamine release after stress had a lesser decrease in frontostriatal connectivity. They stayed on this blue line, meaning that when activity in the VMPFC was high, so too was activity in the caudate nucleus, which could mean that this increased control did not happen and that this was maladaptive. How is this then related to rash action? Well, as you remember, all of our participants also participated in our ESM study, so we could link our neuroimaging findings with daily life. And that's what you can see here. We've got our brain with dopamine release in the left and right VMPFC, and here we've got a relation between stress and subsequent rash action in daily life. The middle line is the overall relation, meaning that when participants experienced more stress at one signal, they were more likely to then display rash action by the next. And then we saw that participants who displayed more dopamine release after stress had an increased relation, meaning for the same stress level, they were then more likely to display rash action by the next signal. In other words, Participants who had more stress-induced dopamine release had more daily life negative urgency. Let's recap. We saw that stress causes dopamine release in the frontal cortex and a decrease in frontostriatal connectivity, and that participants with more dopamine release had a lesser decrease in frontostriatal connectivity, and that this was related to rash action in daily life. Now, those were the results of all of our studies. Let's bring them together. We saw that in patients with bulimia nervosa, negative emotions can lead to binge eating through craving and rash action, but also to not eating. In our patients with an alcohol use disorder, we saw that both negative and positive emotions predict craving, alcohol use, and binge drinking. Next, in our MRI study, we did not find that stress increases the preference for food now in patients with bulimia nervosa, but does cause changes in activity of the occipital cortex. Then, we saw that stress does increase the preference for immediately available alcohol in patients with an alcohol use disorder, and that this is related to change in activity of the right supplementary motor area. Finally, we saw that stress causes changes in dopamine release and frontostriatal connectivity, and that disturbances in these systems can lead to rash action. Now, what does this mean for the clinicians among you? What does this mean when a patient comes into your clinic? Well, if a patient with bulimia nervosa comes into your practice and says, when I feel bad, I crave cookies, I can't control myself, and I have a binge eating episode, well, then you should focus on this relation, identify the triggers, and try to treat it. But you should also explore how negative emotions lead to not eating, because we know that not eating in and of itself is a predictor of binge eating. When a patient with an alcohol use disorder comes into your practice and says, when I feel bad, I just can't control myself, I have to drink alcohol, you should explore this relation. But you should also look at how positive emotions are related to alcohol use, because this could also lead to a relapse. Finally, we need more research on how we can impact craving and rash action in daily life. There are promising studies, but we need more information. And we need more studies on binge eating in general. In our study, the participants were at the beginning of their bulimia nervosa and alcohol use disorder. But what happens before? What happens when patients develop the disorder? And what happens when they are struggling for a long time? That's something we don't know yet. Next, we had very strict criteria for our psychiatric disorders, but patients can binge eat and binge drink without meeting these criteria. So we should have studies that look more at binge eating and binge drinking across the entire spectrum. Finally, we saw the benefit of combining neuroimaging and daily life results in our PET-MR studies. But this should be done more to actually combine daily life data with neuroimaging data and look more comprehensively at binge behavior. This was my PhD. I thank you for listening.